it asks just for velocity. Now it says that, okay, you have velocity. I need you to calculate the forces. So you have so many data here. Diameter is 4 inches. Velocity at point 1 is 1000. At point 2, you found 219, if I'm right? Or 1. 1 is here, 2 is here. What else do you have? The rest of the data are here. Yeah, V2 is here. So V1 is from previous example we had. And it says, what's Rx? So I won't take all data that I need. V1, 290 feet per second. V2, I will write it one more time here, 1000. Rx question. That's all I have. I will say that. This is I will keep that. You keep this one as the way it is. I'm just going back 1 second because it said steadily. The word steadily means that this one is 0. So I just have this one, CS U rho V N dA equal to all forces. What's the force that I need to find? What is the force? What should I write for the force here? The picture shows that. And I would be more than happy if you give me the hint and says that I consider this one as X. So this is positive because direction matters here. And you can look at that Rx based on the picture. If you don't have picture, I don't care. You can consider it like reverse direction. But here it shows like that. Do I have any more forces like weight or any other forces? We have weight, but do we have any information like mass? And if we care even about that, weight is downward. I'm just working on X direction. So even if it's important, I cannot consider that unless I'm going to find Fy.
You have the pressure times the area.
Exactly. Pressure produces force. So I have P1 and P2. P is pressure. Yes. Too late for that. Pressure, okay? So to make it force, area 1, area 2. What's the direction? Pressure is always toward the cross section. So if you look at the picture even, you can find that this is positive, this is negative. So important about the direction. Let me make it a bit neater here. So V1 equal to 219 feet per second, Rx. So I will continue to write that. This time I'm going to use M dot, but you are okay to use Q or whatever. So This one I will write U1 because cross section number 1 multiple by this row, this V, this area reminds me of M dot because M dot is row VA plus I have another section U2 M dot 2 equal to same that I have here. Just the direction. Here I have velocity, here I have velocity. N is out, N is out. So opposite, negative. Same, positive. Since you have just one temperature, oh, you have two temperatures. So for this one, you need to find M, but based on the ideal gas law that we just talked about, that you have pressure, you have temperature. So you can find rho. If you do that, you will find rho to 0.297 slug per second. Ideal gas law, you don't have rho, you don't have density, you need to find that. And pressure and T is here for you. You know the R as well based on the tables, 287 if I'm right. And conservation of mass help you here. It says that m.1 should be equal to m.2. So I will replace them with just one of them, m.1. U2 negative or minus U1 because this one has negative equal to minus Rx P1A1 P2A2. If you replace all the data that you have, U2 was 1000, U1 was 219. Rx, you want to find that. P1 is 100. Area 1, the diameter, you have that. So pi 4 divided by 4. P2 is 18.4 multiplied by the area is the same. So no need to change that. And here you have rho, which you find that, this one. Velocity and area, or you have the Q as well, I think. I don't have the exact number, but you can find that. Do I have it here? No, so I just will write Q and you will be able to find that. If you do that, Rx is 793 lb. That's the final answer that you should. Oh, for Q, you can use V1A1 or V2A2. I will go with 1 because I said 1 here. So I think I should just leave the last 2 examples for you. There are 2 more examples, which I'm going to leave it for you.